Welcome to EDU World Space.
Have we have here, this is the y on the x-axis, and we have some function here, f of x, that is not necessarily positive, as we can see all the 0 for y is here, so f is not necessarily this is not always positive all the times, always positive, um, always greater than 0. So how we compute s sub f, the surface surface of revolution, by rotating. So that we're gonna rotate this function from a up to b. So well, the function uh, doesn't have to be positive for to obtain this surface of revolution by rotating this function, because we can, as you can see here in the drawing, just can rotate that to obtain something like this, and or we don't need that our function is always positive, because that is that surface there is well defined. So how can we compute S of f? So this is the surface of revolution about x. So well, as you can see, assume that this point is C. So we have that f of x. Well, f of x is this original function. So you have that f of x is positive between a and c, and f of x is negative between c and b. So well, what we can do is we can compute the area for this portion, which would be just the same area, f of x times 1 plus the derivative of f of x squared dx, and then the integral from a up to c to pi. And then for this one, well, we can just flip this part, and then to make uh, this positive, minus f of x is positive. So for this case, we just put a minus, and then this would be the area. And well, since this number is a square, it doesn't matter if f prime is positive or negative. No matter if f prime is positive or negative, the square is always uh, greater than or equal to 0, so that this is part is fine. So we will do this part plus that part, integral from a up to b of that. So then s sub f for this function, for this particular example, is gonna be 2 pi times the integral from a up to b up to c of f of x times 1 plus f prime squared dx plus 2 pi times minus f times the integral from a up to b of 1 plus f prime squared dx. So well, that works for this example. We have that that is becoming negative at a point. But if we have an example of this is the x-axis, this is the y, and then we have some points A and B, and then we have that our function is like this, where these points are C and D. Well, by the same considerations, S sub f, that is the area of rotation about the x-axis, is gonna be the integral from A up to C of f of x to pi times the square root of 1 plus f prime squared dx. And then between C and D we have to flip the sign of f, so 2 pi times minus f from C up to D of times 1 square root of 1 plus f prime squared dx. And then from C up to B is positive, so that the sign from D up to B, so that the sign of f is unchanged, so it will be 2 pi times f of x times the square root of f prime of x dx. And well, in general, the same would happen if the same happens um, if f has several intervals, where if f is negative at several intervals. So as you can see, what we are integrating here, this is the absolute value of f of x, and since f is positive on that segment, this is also equal to the absolute value of f of x, and this is also equal to the absolute value of f of x, because along this segment f is positive, along that segment is positive, and along that segment f is negative. So in general, the most general way to write this integral is just the integral of the absolute value of f of x, and while this part remains unchanged, so the absolute value of f of x times the square root of 1 plus f prime squared dx. And so it doesn't matter if the function is all the time negative or just negative at some intervals. This is the general formula for finding the area of the surface of revolution about the x-axis. About x-axis. The general formula, no matter what is the sign of f